got these things pulled loose, and you can see that this is primo, okay? I couldn't ask for anything better than how this one came out. Now my first one, I had a little bit of a learning curve, and also too I had to change my plugins, make sure that I was plugged into a little heavier duty, because I was pushing a full 60 amps for too long for my 60 amp breaker to be popping. And I think in the future I'm going to do something about that. But what I did is I changed it around so I didn't lose power halfway through this one. All right, this one here I did lose. I lost power when we got to this back edge right here, and then I had to restart, and then it blew back. So I have a couple little scars I'm going to grind and everything else out of here. No catastrophe. I'll still be able to use the part, and the inside and outside are just absolutely beautiful. This is just a little bit of a feathering where the start and stop of the cut is, and this flashing just will knock off of there. We'll get it from the other side there. So they're hot. I just can't grab a hold of it and work on it right. But that's something. All right. Now, you know, I mean, here I talk about glorified bragging about being able to plasma cut and speed and all of that kind of stuff in your thickness. But if you slow down and you take, you know, and set downset your settings, you can get good quality cuts on the edge, and that's what this is all about. I mean, this plasma cutter is not even supposed to be cutting 1 inch. I think it's supposed to sever 7/8, and it pierces 1/2 inch, and it comfortably cuts 3/4. But I bring things down 60 amps, 5 inches a minute, and that get her done. Alright, I run the indicator against the face here so I can see it running out here. It's not important that you actually see it. You just, you know, I'm not going to lie to you. I'm just going to tell you we got about 15 thousandths. That's the high, and that's the low right there. And then I'm running a surface gauge here with an indicator right here so I can look at this edge right here. And I just keep a constant view down this way here, and then I can watch it kind of go in and out. And at the same time that I kind of adjust it, I'm adjusting it this way here. It was about 1/4 inch, and I'm just slowly bringing it in line. Alright, now we're just a little bit out, side to side, just a tiny bit, not much. Okay, we're probably within about 25 thousandths on our round to round peripheral of the bore. Alright, and we're still, yeah, we gained a little bit. We're about 18. So I'm going to take the low side right here, and I'm just kind of working it. That was, I took 15 and it just a partial of it. Alright, there's 0. 22, back to 0. It might be just because of the tension on this jaw here. All right, we went down. We're running about 10 right now. All right, that's about 5. I'm just going to tap in on the high side. Well, we're just going to, let's forge off, because that's really the best way if it has a little bit of warp to it. So there's 0. We got -4. We got +1, 2. And we got -2 right there. You know, we're pretty true there. Let me see if I can just tap this in. -4, -2, -4, +2. All right, we're almost equal right there, within 1,000. Let's go ahead and let's cinch her down here. Okay, that looks good. Okay, that looks like I'm probably within 25 thousandths. You wanna let's test that out. Let's see if I am. See if I can get this indicator in here. And see if I can get it to where you guys can see it. Alright, let me see if you can see that indicator. Alright, that'll let you see it anyway. Alright, well, we're gonna put that on 0. Alright, now one way I think is easier on this bump than the other way, and I think if we go this way here. Okay, there's 5 it went up to, -5. It jumped to +10 there. 0. Alright, so using your surface gauge and watching that edge right there and keeping a constant view, you can bring something in really close. Trust your eyeballs. If you want to, double check them, something like this. Alright, let's get set up and we're going to do some cutting there. This is my go-to boring bar, and it is, I like it because it holds my regular CNMP or CNMG inserts. And I do enjoy those inserts. You know, they do almost all of my cutting. I'm not saying that there's other ones out there that won't do as well, but I just, you know, when you got something that works, you know, why change up? Alright, I rotate this around, just making sure we got plenty of clearance and I don't have any crashes there. And I'm going to leave this sticking out like this, but if it was giving me a problem, I can shorten that up. But I don't foresee any because it usually cuts pretty good at that distance out. Alright. And here again, this is like 265 RPMs. Almost time to go get a new brush there. I'm losing my hair. Alright. I'm just touching off there, and then I'm going to feed in at that diameter. I know that the inside is probably a little bit smaller. This is the first time cutting plasma cut on the AR plate, so I don't know how well it's going to do this or not. Just watching the color of the chip. After the plasma cut, I just let them air cool. This is AR 236, I think is what it is. That looks pretty good. Insert looks pretty good. Well, let's go for a little bit more. This bore kind of finishes out about 6 inches, and we're like at 5.5 right now, so we have quite a bit to come out of here yet. But we want to get underneath that scale first, you know. Let's give it some speed. All right, let's try 50 thousandths. Hello. Hey, buddy. Pretty good. Turning some AR plate in the lathe right now. Yeah, it's not the softest stuff in the world, I'll tell you. Yeah, this is just AR 236. It's not real tough shit like the 500 or anything else like that, but I tell you what, there's no, I mean, it's so hard, the color isn't even blue. It's like gray black, you know. We changed our index here, and let's see if we can slow this down a little bit more. Alright, we just need to know where we're at here so we don't take too much. Okay, about 6:30. There's another 50,000 aside. Better, and the chip's not quite so hot. It's coming off pretty much a white goldish color and then turning blue afterwards. That's a better looking chip for lasting a little bit longer on the insert, so I'm kind of happy with that. Alright, we're just going to open these up to size and get them ready to weld onto the sleeves. Alright, we got our big boring bar in here, and we have a boring bit in there, and it actually has a pretty good angle on both sides, so we're using the bit itself to come in and kiss the burr on the back side. And we're just lining up our edge there. We just want to break that edge right there. Let's see if that's going to be enough. Okay, it feels like it's gone. It's not much, you know, it's just yeah, I like that. Okay, we're going to put our other boring bar back in here because we're going to go ahead and put a weld prep on here. Now we're going to go ahead and we're putting it in 30 degrees from our face, so we're going to, the other, on the tube itself, we're going to do it in the other direction there. It's going to be a shallow, but it'll be a 60 degree open weld prep. kind of thing. I want a little bit more. Okay, that ought to be enough to join that up and let that get penetration and reface the end of the tube here without getting too crazy. And the rest of this looks like it's it'll be a press fit on the sleeve itself anyway. That's what we plan on doing. Alright, let's get the other one in here and get it to the same as this, and then we're going to start friction driving the tubes, bring them down to size, prep them for this, get them welded, and then bring them back in for the final machining, and then the project's done. Alright, we're done with the boring bar. Alright, and we're going to go ahead and pull this out. We're going to clean up our 4-jaw, and we're going to remove it. We're going to put a 3-jaw in. We're going to get the base part of the lathe all set up, because we're going to start working our tubes. And I want to go ahead and switch over to the 3-jaw, because I'm going to be wanting to hold it freely out here and do a little bit of machine work, and its jaws will hold that sleeve where I want it to do what I want to do on the end of it. And then we're going to be holding a slug that we're going to turn to register it, and a cap to register the other end with the center drill in there, so that when we weld these on, we're going to be able to do the machine work to this and do the finish turning on the OD all in one setup. So that's the plan anyway. There we go. Alright, get wiping that down and getting our mess all cleaned up. This is a 6-inch diameter piece of cold roll we got. It has multiple machining in on this side here, and it has some machining on the other side, but I put parallels back here so that we got it running true in the 3-jaw. Now I'm going to go ahead, we're going to be just breaking this chamfer here, this one here, and then we're going to go ahead and set up a 30-degree angle so that we can copy the angle of our large bell center, and we're going to be turning a nice taper in here. After we turn this taper, then we're going to be chucking up on a slug to where we can push this part against, and then we're going to machine a diameter and a shoulder and skim this OD here so that we can use this to drive or support the end of our long tubes to turn the sleeve and the face on the one side that we're going to weld the plate to. That's kind of what we're going through, and I just kind of want to explain what we got here, and I'm going to be buzzing through this so I can catch up with the project at hand. So I'm not going to be showing all the video of everything, but I am going to kiss that surface, face it off. I'm going to break that edge right there, and then I'm going to cut the taper here, and then we're going to get it up against another plate, and I'll bring you in when we get to that point. Set up here with our boring bar, and now we're getting ready to cut the angle in. This dressed up nice. We wanted to make it so we didn't have any sharp edges on it. We kind of broke it all down there. Okay, I like that. Looks pretty clean. Now, the reason why I mean, it could be real narrow, but we wanted to give it a little bit more stability in here. But this is going to basically act the same as putting a live center in here. And we're going to go ahead and put a little sharp. You see how close we are on this this angle here? We can we can change our angle a little bit. Actually, I probably should put the it in the tailstock, and that would give us a better idea. And we might be riding out here at the major diameter here. And we're going to go ahead and put a little Sharpie on. On here, see where we're at. And that's what it is we're out at the major diameter. Alright, I'm going to go ahead and I'm going to kick it about a skosh off the degree here. There's actually two little tiny scribe lines on my compound here, and I had it on the shallow one. Well, let's give this a try and see what we got. Okay, let's see if this fits a little better now. Oh yeah, it actually feels better in there too. Okay, I think we're darn close here. And I'm going to put the bell in here. So we can get a true alignment of this. Okay, now let's see what we got here. And we're still out towards the outer edge there a little bit. And we're reading the same thing right there. But we are seeing a little bit on the bottom, but not on here. Just up here at the top. You know, that did pretty good. I think I'm gonna be happy with that angle that I got right there. I just kind of see that the paper's kind of really rubbing it nice and even there, and I'm not going to nitpick it any closer than that. All right. Now, this side's pretty flat, and we're going to go ahead and we're going to take that one little burr off of there, on that side there. We're going to set this back in with the parallels like we did the first side. I don't necessarily need to take anything off the face. I just want to break that inner edge there. Okay. That's looking good. Alright, we're going to move our compound back to where we were and break that edge. We put in this 4-inch slug because it had a machine surface here. We faced this off so we have something that's solid that we can push against to friction drive this. We're going to move our carriage in here so we can keep this as short as possible here, and we get a good firm tension on our tailstock there. And I like to go ahead and make sure that my quill is tightened because it has a tendency to sag. And this is still semi-loose, and I'm going to just start rolling it and then tension it as it's rolling. I find that centers it. If you have it hanging and your tailstock is just a skosh misaligned at all, it'll sandwich that in there, and then it holds it. By letting it run, it spins and lifts what needs to be done, and when you got the pressure against there, you're riding 100% true, and your center and your bell and everything else does not wobble. Just my practice. You know, maybe it's unnecessary on all machines, but it is necessary on mine. Alright, now we want to turn this diameter down so that we have some working diameter on the outside of our sleeve, because we're going to be turning a weld prep area, and then we're going to be holding it and flipping it back and forth. So we want it to have enough meat there to hold the outside of the lip, but we want to have enough clearance so we can come in and we can do a little weld prep on the outside diameter as well. So the OD is 6 inch, the ID is 5 inch, so we're going to kind of bring it down in between there. Cut should take us right on 5.5 here, or within 10 thousandths of 5.5. Okay, I'm going to get on the side here just because I'm right-handed. Okay, and we're 6 thousandths under 5.5, which is fine. Alright, now we're going to come in, well, we're going to break that edge there, but we're going to come in and we're going to cut a shoulder that's 5-inch diameter here with a landing, about halfway here, so that we can slip that into the bore, and this will register one end of the tube while we're doing the machine work on it. Alright, first we're going to kiss this off. That looks good. Alright, we're going to touch 0 here. And we know basically we got 1/4 inch shy, a couple thousandths of actually going in. We're going to take 50 at a time. And I'm going to go ahead and I'm going to feed this by hand for right now. Now see how this is rolling up in front here? It's probably a little bit of a wear on there, and that's a CNMG bit there. Alright, I'm going to go ahead and take another 50, feed it by hand. Check our diameter there real quick. Okay, and we're down about 280. That should be about 180. and a half. Get rid of these chips before they go flying out on my face here. Okay, I'm going to run a little feed here. We'll give it a shot. Alright, 80,000, 80 and a half left. to take the 40 and go for it. Okay, I came, kissed the shoulder, went back in, relieved down a little bit so I don't have any sharp edges in there. Alright, let's see what we got on the diameter here now. We're looking for 5 inches. We got 5 and 5 inches, 1.5 thousandths right there. Let's lock this just so we don't twist it. Yeah. Alright, I think we're going to leave it. I think we've made our bores at 5 inches, 5 thousandths. I believe that's going to be perfect. Alright, let's go ahead and we're just going to break this edge here, and then we're going to try it in a sleeve. It's close enough where if you don't get it right, it just wants to grab on you. Alright? Alright. You know what I'm saying? Let's see. I don't know. You know, I've practiced a couple times here, and you don't have it exactly right. Everything works better when it's off camera. Alright, take 200. Ta-da! Alright, we're starting off by going ahead and basing these off the length. 11 3/4 is our overall height of the sleeve, or the length of the sleeve. I just went out to the mail and I had another nice care package, and I just received some inserts, and what I'm going to do is I want to change out this Arno insert before we do any damage to it, because I do want to try it out on marine shafting yet. That's what it was given to me to try out on, and so we're going to put that in our box here. Now this insert that we're going to put in here and try now is a Kennametal CNMG 432, and it's a grade, I think, KC 950. And I'm going to drop this in here, and we're going to, of course, we're not hogging off a whole bunch of material here. We only have, another, I don't know, maybe another 30 thousandths here. Let's see what we got here. Well, we got about 80 thousandths to take off the face here.